This work started really quite a long time ago. We were trying to develop a test to detect tuberculosis rapidly, and we developed one, and it worked quite nicely. The problem was it was difficult to use because it involved, working at the bench here, and that's not really where TB is diagnosed. So then we spent a number of years working to adapt that test to a simple cartridge system, which is really a laboratory in a cartridge. Finally got that to work after working to raise the funding and getting a bunch of collaborators together, and then got the clinical trials done, and it looks like it's a very good test, and finally the WHO approval, so it's going to probably be used in a lot of places. Well, when TB was discovered, it was discovered by observing bacteria under a microscope, and essentially that microscope is still in use to this day, and the problem with that technology is that it takes a long time to diagnose one case of TB. You have to look at 100 to 200 high-power fields in a microscope, and that can take upwards of 20 to 30 minutes per sample. And it can't detect all cases of tuberculosis. It wasn't bad in the days before HIV, but now that we have HIV, about between 40 and 60% of cases can't be diagnosed under the microscope. Our test, on the other hand, takes about 2 minutes of hands-on time, and the whole test takes about 2 hours. And not only does it give us data on whether there's TB or not, which is far more sensitive than the microscope, but it also tells us whether there's drug resistance. When TB comes into a laboratory, it comes in a sputum cup, which I will show by using my hand. And when the sputum's in the cup, we take a reagent that we've developed, and you pour it into the cup, you seal the cup, and you shake it, and you put it on the bench for 15 minutes. Okay? It's not too hard to do. And then you take one of these cartridges, you open it up, you would take a pipette, and you would pipette from the cup into the cartridge, close the lid, and put it into this machine here. Close the door, press a button, and that's it. Everything else is done automatically. In this country, when we think someone has tuberculosis, we bring them into the hospital, we put them in an isolation room, and we collect 3 sputum samples, and only when the 3rd sputum sample is negative for TB, by microscopy, do we let them out of the room. That usually takes 3 to 5 days. So you have a sick patient in an isolation room where people put on masks and gloves to go into the room. We're hoping to show soon that with this test you could do one test in the emergency room and decide right then and there whether they have TB and need to be in isolation, or whether they don't and go on to the wards. It's a huge saving in cost and a huge saving potentially in morbidity and mortality for patients. In the developing world, where there's a lot more tuberculosis and HIV, there are other places this can be really life-saving. It turns out that if you take someone with HIV and treat them with HIV medicines, if they have tuberculosis and they have advanced HIV, the TB actually takes off and they can die very quickly of tuberculosis. And this group of patients is a group that is the hardest to detect TB in. Usually they're microscopy negative. So essentially we're treating people with for HIV, and they're dying of tuberculosis without it being diagnosed. They're dying within weeks. So with this test, we can hopefully, and this hasn't been proven, screen patients who are getting treated for HIV, catch their tuberculosis and treat that too. And it's going to make HIV therapy in Africa much safer.